Thank you, Stephen. A number of guests duly introduced by fellows beg leave to attend your meeting. Is it your pleasure that I welcome in your name? Thank you. Minutes.
Of Thursday, 12th of December, 2024, were read and signed. The names of 14 candidates will be put to a ballot, which closes on the 6th of March, 2025, were read. The following communication was then laid before the Society: St Kilda, a Rosetta Stone for early sheep races in the North East Atlantic region, by Professor Andrew Fleming, FSA. Thanks were returned for this communication. The President announced that the next meeting would be on Thursday, the 13th of February, 2025, and then adjourned the meeting. A reception followed.
Is it your pleasure that I sign these minutes as a true and complete record? For those of you who didn't catch up with it, the meeting that had been planned in Exeter last week had to be cancelled because the speaker was unwell. We now come to the main business of today's meeting, which is to hear a lecture, our paper, Fueling the Anthropocene Technology Networks and Environmental Impact of the Bronze Age Steppe Metallurgy. Dr. Miljana Radivojevic is Associate Professor of Archaeological Science at UCL, the Institute of Archaeology, my alma mater. She specializes in early metallurgy, particularly copper making in the Balkan region. She did a PhD in archaeometallurgy, and her current research spans fieldwork and laboratory analysis across Europe, Central Asia, and into China. She's published over 30 academic works, including a book, The Rise of Metallurgy in Eurasia, in 2021. She's an honorary fellow at Cambridge, serves on the British Kazakh Society Education Board, and is a trustee for the Institute of Archaeological Metallurgical Studies and the British Foundation for Women Graduates. She's recently, I'm very pleased to say, secured a major ERC grant to fund her work on Bronze Age metal technologies in the Eurasian Steppe. And we very much welcome her this evening to give her lecture.
Thank you very much, distinguished members of the Society of Antiquaries, and thank you to all the guests that made it today. Really made me smile, seeing so many friendly faces and faces I haven't seen in ages. So thank you very much. So today I'm going to talk about a research that is actually ongoing, but I stand here in front of like a decade or more long research in the steppes. That I've been doing also with my colleagues. So this is a teamwork, not only me, but I'm proudly presenting it as the project manager and as the director of research, so to speak. So where we are when it comes to Anthropocene, there are many theories when Anthropocene starts, but the ones that we're going to stick with is going to be the early Anthropocene with a small a, with A minor. And looking into the Neolithic and the Bronze Age and the impact of agriculture and domestication and other activities that were taking place and impacted the carbon emission. I would like you to pay attention to actually this slide and the top two graphs that you see, which is the emissions of methane at CH4 and the emission of CO2, carbon dioxide. So what is happening is on the left-hand side, we can see that the blue lines and the blue region is where we should have been, but we are not. We are along the red dots. And the wrong start or the wrong turn was around 5,000 BP, which is just about the Bronze Age. There's massive research done by Professor Dorian Fuller at the UCL Institute of Archaeology, I'm going to mention just in the next slide. But these CO2 emissions are still underexplored. We also see the wrong turn, if you like, around 6,000 BP. This is when the red dots start actually going up. This is a way of no return, fortunately, but we can see where it's kind of started to go wrong, and it's just around the Bronze Age. So what impacted this is going to be a topic of this research as well, and this presentation. So the methane emissions and the Bronze Age wet rice cultivation are actually a known research by Professor Dorian Fuller, as already mentioned, and he already showed that wet rice agriculture was responsible for the higher emission of methane in the air. But let me go back to actually where I think the carbon emissions sit at this stage. I'll take you back to the time of bronzization. This term was very cleverly coined by my colleague, Helen van Kilden, setting it in the late Bronze Age, between 1600 and 1200 BC. And this vast region is actually showing that the tin bronzes at the time were actually connecting Atlantic and Pacific in one big space of like pre-modern globalization, if you like. What is interesting is that only in the outer part, we have the Shang dynasty, Harappan dynasty, Mediterranean civilization, Egypt, Mesopotamian civilization, but the kind of the upper spaces, the northern spaces, were kind of thought of as barbarian, if you like, but those were the places where you actually have the tin ore, which are here represented with yellow stars. And this is how they look like, both cassiterite and stannite. And tin was the necessary ingredient to make bronze. I need to pay homage to the man who's done a lot to actually move this study in the Bronze Age Eurasian Steppe. It is my dear colleague, Evgeny Chernik. I hope he's actually listening online. He's still very vital. He did more than 50 years of research on Bronze Age metallurgy in Eurasian steppes, and he came up with this idea of metallurgical provinces. What are metallurgical provinces? Those are actually regions that kind of start with metal production early on, like in the Balkans, where we have these early massive artifacts, late 5th, early 4th millennium BC. And then we move that, so to technologies move eastward, where we look at the circumpontic metallurgical province represented by cultures like Mycop, sensational burial mounds, no traces of settlements, sadly, but lots of arsenic, copper, and silver, and some gold. So massive gold production, actually, in this region. And then as it explodes, if you like, we are in the 2nd millennium BC, where we have the Eurasian metallurgical province that is characterized by literally connected spaces between East and the West. We have cultural complexes like Andronovo, who are responsible for making the arrowheads, the spearheads, the halberds, lots of chisels and axes that were actually seen typologically similar across the entire space. And we have phenomena like, say, Maturbina, which is not a culture, but more like a fashion, like Teslas, if you like, of Bronze Age, where we have the production of really high-quality tin bronzes moving from the Altai towards the West. So it goes both ways. So the idea behind the metallurgical provinces is that these spaces were actually culturally or compositionally in terms of metals homogeneous. And that is how the theory stands right now. Chernik estimated more than 500,000 artifacts from the Bronze Age currently present in museum archives. So you can imagine that the real number of artifacts made at the time could have been 10 or 50 or 100 times more. That's something to be explored. So why these spaces? Why are they interesting? Where we have tin in Kazakhstan, in Altai Mountains, in Uzbekistan as well, along the tin-bearing rivers like Irtysh Valley, and we have a lot of copper. But because tin is located in Kazakhstan, we have these communities actually engaging in making tin bronzes and being very important agents of change, if you like, at the time. The tin mining districts, the most famous ones are in eastern Kazakhstan and in the Russian Valley in Uzbekistan, but there's more to be uncovered for sure. And many of them are destroyed because we have in the middle somewhere here, the Jeskazgan mining region, which is basically the largest mining deposit that is still currently being exploited in Kazakhstan. So here we are when it comes to the Bronze Age Eurasian steppe. It is usually thought in scholarship that the steppe people were the barbarians living at the outskirts of the civilized worlds. They were chasing horses, herding goats, and pretty much just living unbothered with what was happening with the rest of the world. However, we know that because of these resources of tin and copper, they were actually feeding the emerging political leadership of the old world, of the outer Eurasia, by trading and supplying tin and copper and maybe raw metal as well. And therefore, one can argue that these inner Asian spaces fuel the most global economic network called the Silk Roads, but maybe at the time they were called the Bronze Roads. The key to how and why is to look into technology, organization, interconnectivity. Why? It's because this is the most abundant source of materials we have. We have many theories being made about the movement of the people in the steppes based on DNA, based on organic materials like seeds or botanical remains and so on. And, you know, with all obviously respect to that research, there is more happening when it comes to analyzing inorganic materials that are much more abundant and much more easily accessible, to be honest. So big debates require high resolution data. And this is where my expertise comes in. So I study everything that comes into the furnace, like charcoal and ore, and everything that comes out of the furnace, like objects and metallurgical slags. Metallurgical slags is the love I inherited from my supervisor, Tiller Ehren. They are way too ugly to be exhibited in the museums, which is what makes them a perfect material to cut. Everyone is going to give you a piece of slag. No one's going to give you a piece of metal to cut. What is important about these slags is that you can see inside these slags a whole world, a whole story to make about how metals were done. So knowledge provenance, supplies networks, circulation networks, scale, standardization, land use, environmental impact, you name it. This is the most precious material and it doesn't travel, which basically gives me a story about what was happening in situ on the spot where I studied it. So I'll give you a few kind of highlights about Bronze Age steppe metallurgy. It is innovative technology. We have this exceptional craftsmanship in tin bronze production. I've already mentioned the Seyma turbine of metalwork. Seyma turbine is basically, I told you, the fashion of these really highly beautifully done tin bronzes in a perfect ratio of 10:1. So 90% copper, 10% tin. And it was basically blossoming and exploding across the whole space. And just to give you an idea of what was happening before, it's mostly agricultural tools, so nothing really nice to look at. And then we have new systems of furnaces for large-scale smelting operations. This PhD project has just been finished by my postdoc and a colleague to be, Ilaria Kalgora, who's here. So I can give you more insight about what's happening with these large-scale smelting operations. But what I can give you as a hint is that this is the site of Taldisai. We don't know where these people were sleeping, but we know where they were making metal. The idea is maybe they were sleeping next to the furnaces, judging by the excavator, but the whole site is just metallurgical workshops. It basically gives us an idea that it could have been maybe a seasonal settlement, but it is a massive scale operation. So we are in Taldisai. This is how the furnaces might have looked like. So it's a chamber with a long channel that is covered, and there's a chimney at the end, and it's usually the principle of differential pressure. So heating one end to have the other end hot as well, and basically, you know, playing with the opening and closing the holes so you can actually control the temperature. I am hoping this may not work in here, but this was like this is a video of the shaft furnace, but you can just see that, you know, how it might have looked in the field, and we have like several of those available. So here is the reconstruction from Kazakhstan from our colleagues in Almaty. This is a wishful thinking, but we are still working on it, to be honest. and then we're gonna get to the chamber. Yes, in a sec. So the idea is to load the chamber with wood. There's little openings so that we can control the air supply. And then this long channel will be used for controlling the process, so in and out, or maybe getting rid of the toxic fumes because they were smelting primary copper ores that were loaded with sulfur, but also making arsenical copper. That's one of the working ideas. And ideally, one would have gotten metal at the bottom. This is the ideal of reconstruction. We are still working on how functionally it could happen, and we are experimentally reconstructing it at the moment. So this is basically the same thing. And important thing to know about these furnaces is that they were not found anywhere in Europe. So this is definitely a new way of technological mind, if you like, thinking of how to scale up the operations in the steppes. And we see the development of these furnaces very early on. We see them in the Middle Bronze Age from Sintashta sites with some big, there are holes in the ground with like with water, or like from other side, Aktau, I think, or different nearby sites where we have these little chambers and a little bit of a longer chimney. So it shows this evolution in technological thinking of how these furnaces might have become. But I can tell you they're very unique for the entire space of Kazakhstan and well into Uzbekistan. And they show and tell us about different way of thinking about how to actually scale up the operations of metal making, how to make more metal. We know from experiments that in one of these chambers, you can make up to 800 kilograms of copper metal. So that shows that it could have been because of this scale of operation. So how do we reconstruct the metal making process? We look at these charts very roughly, but they represent different processes such as roasting, crushing, smelting, first time, smelting, second time, getting rid of the sulfur, getting rid of the iron from the slag and from the metal, and then getting more or less workable metal you can smelt further and so on. So we know from Taldisai we have these processes present, and we know that these are the types of ores being used. In a great detail here, I'm just going to give you a scoop of what is happening here. In Taldisai, we have different production lines. We have copper metal line. This is the same sort of a diagram that is being used, but a little bit more elaborated with a little more evidence, because this is the PhD research just defended and to be finished completely by Ilaria Kargaly. And it shows this joint step of smelting in vaulted pit furnaces. Then we have the arsenical copper production in line B, where we have a little bit of more of a complex smelting copper, but also doing some arsenical copper smelting, maybe in the furnaces that look a little bit different in Taldisai. All of that, the initial research has been published in JAS reports recently, so you can just look it up. And what is important to say is that looking at these different lines of production, we have copper, we have arsenical copper, we have copper arsenic tin. All of that is corresponding with the types of artifacts we find in Taldisai. What is interesting, looking at the recipe of production, for almost 400 years on this site, we see really sustainable production. We see the replication of the same recipe all over again in these big furnaces regarding all these lines of production, which is an interesting case in hand when we talk about knowledge transmission and how metallurgy actually spread in the steppes at that time. We've been going a little bit further, looking at the whole database and available sites. So building the project I'm going to present at the end of this presentation, there's more than 144 sites with interesting finds, with lots of data that we found. The data quality on its own is under discussion. So we just have to work the tier system of what is better quality, what is lower quality. But there is enough data to start actually telling a different story. Because what was happening thus far, we know the story about the metal production in the steppes based on metal artifacts and their composition, but we don't know from the process of the making metals, which is more informative. This space is super connected. I've been working, and this is a case study in Southeast Kazakhstan in Almaty with Professor Michael Fraschetti in the sites of Dali, Tashbash, and Begash. They look beautiful. The landscapes are amazing. I am yet to visit it. I'm promised they will build facilities rather than bathing in the river nearby. But it's got like 5,000 years of human occupation, and I was looking in the production of metals in both sides. What was truly fascinating is that we can actually put together all these dates like data clouds. So I have data in this pink cloud from Southeast Kazakhstan. I have data from central Kazakhstan in this yellow cloud. I have data in Northeast Kazakhstan in this green cloud. I have data from East Kazakhstan in this red cloud. And these here are the marks for the mines being sampled. So now we can start slowly to build a picture about what was actually going on in this part of the world. So I'm trying not to be too techy, but I'm just going to say that we work a lot with ternary diagrams. And the idea of these diagrams is actually to show me if I can see any sort of association of data with the ores, so metals data, metal artifacts data with the ore data. And if I can see where they are grouping, so I can figure out what types of ores were being used. So I can tell you for Dali and Begash that they were not made from East Kazakhstan ores, although they are rather close, if I may put it that way, because the East Kazakhstan ores are rich in zinc, but the Dali and Begash have these antimony and arsenic concentrations, and they are very indicative of the use of Falor. When I put all these data sets, and I have more than 240 artifacts from the Bronze Age metallurgy being analyzed thus far, together with the team in Bochum, I can tell you that on this zinc corner, we have the ores, so East Kazakh ores, and only some of the East Kazakh metals from the Bronze Age. But on this corner, in this corner, we actually have much more. We have antimony and arsenic concentrations in really significant amounts in metals coming from all over Kazakhstan. And that is indicative of Falor. But there is no Falor in Kazakhstan, which made me think further, where can I find that ore? If it wasn't in Kazakhstan, what kind of analysis can I apply to actually figure out what was going on? So for that purpose, I've done lead isotope analysis. And to unpack this graph, very colorful, I'm going to tell you that Begash artifacts, which is the campsite in Semirechye, are spot on ores from northwest India, while Dali artifacts are more or less spot on some Uzbek sources and possibly some Chinese Altai sources, but that's under discussion. So let me put this map together for us. We have this data, we have the indication of these mining sources being used, and when we try to draw the line, we actually see that they're very much aligned with this idea of the Inner Asia Mountain Corridor being very important in the building of the connectedness between the Southwest Asia and East Asia. And this is the making of the Silk Roads, if you like, before we know of the Silk Roads, a couple of thousand years before we know of the Silk Roads, actually. What is interesting is that we see the penetration of these elements well into Kazakhstan. And it's also confirmed with the Asian DNA analysis, with the movement of people. We can see actually movement of artifacts, movement of ideas, if you like. But it's just one of the segments of the Silk Road that we see are being actually made and created just coming out of this research. What I think about this trade of Inner Asia Mountain Corridor, I don't think about caravans of camels, if you like. The way to think about them is, as we have millions of little pathways where the nomads are actually moving their sheep and goats for the summer pastures and the winter pastures. And along those ways, they're cutting pathways, and there they can trade along those lines. Because I cannot imagine that the village in Begash on Dali, the people living there actually knew what was happening in a kind of a global, grand scheme of things at the time, but they were just like at some end of exchange process. And we actually have tin along these routes that was important for making tin bronzes. Speaking of the scale of production, how can we measure it? What is happening in Europe at the time is very important, just to give you an idea how important the steppe is. We know from research that there is this transition 1600, 1500 BC from local sources exploitation to regional centers and mining complexes. What do I mean by that? Is represented by this diagram. Say, we have this major shift in metal and ore supply networks in the UK. Looking at the early Bronze Age, we see that most of these artifacts are actually falling into these Welsh regions, so using local Welsh ores. While in the later Bronze Age, we have a bit of a span. We have Welsh ores, we have Alpian ores, we have some of the Slovakian ores. And this is just one example. Like, you can work it down in any sort of a country, if you like. We have Hungarian data, we have German data. We see a big shift towards what is big regional center for exploitation. So around that time, which is a time of bronzization, let's go to Wales. So we have in Great Orme, which is one of the most significant mining complexes in the late Bronze Age in this island, we have the estimate around up to 800 tons of copper being produced at this time as a sort of a rough estimate. And then we have in Mitterberg, Austria, which is the largest European copper mine. In this boom phase, this bronzization phase, we have around 15,000 metric tons of copper being produced, late Bronze Age only. So it's massive. And then we go to one mine in Russia, in Kargaly, which has got 35,000 shafts, 500 square kilometers of coverage, several hundred kilometers of underground galleries, and 150,000 metric tons of copper being produced as a sort of an estimate. And now playing with the numbers, and I promise I won't put you to sleep, but I put the colored text is for us to actually keep us going, keep us focused, is that looking at some experiments that were taking place in late Bronze Age site of Kargaly by the Spanish and Russian teams, I can tell you that with all these calculations, that around 150,000 metric tons of copper metal would have required 75 million metric tons of wood for Bronze Age metal producing Kargaly. For that metal to be produced, and if they were managing the wood resources, we would still need around 37,500 metric tons of wood per year, or annual felling of 150 hectares of woodland. We are in the steppes. These woods do not exist. So the forest today covers 2.6% of Kargaly region. So in scenario one, for the cycle of 60 years for full recovery, which I really doubt what's happening, but says if they were managing the woods, it would require 7 times the size of Kargaly mining complex. And if they had a cycle of 30 years for allowing for the full recovery of initial productive capacity, it would require 3 times the size of Kargaly mining complex. We don't have that wood, we don't have that forest, which is what prompted Chernik back then to hypothesize that maybe the reason why this mine was coming to close in the late Bronze Age, so basically collapsing, is because they exploited all the resources, but there was nothing to be exploited. This is how the industry actually collapsed. And it's something that's really interesting thought to play with, but also to keep researching. And I'm going to talk about that in a bit. So these exploitation definitely must have been beneath the threshold, and it prevented forest regeneration. This is how it happened. So if we model the carbon emission based on these figures, only for scenario one, where we have these 60 years of recovery cycle, this is the figure of carbon. So it's 115,500,000 kilograms of carbon being that emission in the air. This is just one system. This is Kargaly. We have at least 5 or 6 like those. So say for the 5 mining systems akin to Kargaly, we will have more than 500,000 tons of carbon dioxide present in these emissions. And I'm not even touching on Shang Dynasty China, where production was completely, like absolutely out of any proportion imagined in the steppes. We have artifacts that have 10 tons each. So this is something just to be explored, but I'm just giving you an idea about how massive the impact must have been that we haven't thought of yet. So from another perspective, where we take estimates from the number of artifacts, so we have these 500,000 artifacts present in the museums, but if the real circulation was 10 times this volume, then we would have had, okay, I cannot even say it, this figure of wood. And then if we are having the scenario 2, 50 times the extant volume of, of these artifacts, then it would be, well, billions again. Massive, non-negligible impact on the environment in the steppes. So I can just give you the figure that calculating, with all these impact and equivalent of like methane and nitrogen dioxide and all these calculations I did with Dorian, that there would have been 32.5 million tons of carbon being emitted at the time. And it is definitely something significant and something to keep an eye on when we model the impact of metal production on the beginnings of Anthropocene, if you like. Just a little bit of play with figures, just testing the idea. If we put this production efficiency of mining systems here, like more than 500,000 tons of copper carbon dioxide, and we put in these scenarios how much would it be in 32.5 million tons of carbon in scenario 2, or 6.5 million in scenario 1. The idea is how much land we need with wood, and that is the question. So in scenario 1, we need 11 times more land with wood than estimated, or in scenario 2, we need 56 times more land with wood than estimated. So maybe it's a bit blown with the figures. So we have to rethink like what other parameters we can take into account. But one thing is definitely sure. What we see today was different from what was existing at the time. And there must have been some impact, some deforestation that was taking place in the steppes that was basically transforming it from the time of the Bronze Age metallurgy onwards. So my question is like, are we missing more mining systems in the steppes? Or are metals coming from beyond the steppes? Are there enough wood sources? What if they were using dung? Today they use kizyak, so dung is used in Mongolia for cooking temperatures, but you cannot raise the temperatures with dung to 1200, 1300 degrees. So there must have been some sort of a mixture of charcoal or wood and dung. It's something to be explored. Where are these resources is my question. And how can we actually research this question? Is it by looking at the phytoliths? Is it looking at the microcharcoal? Is it by taking the cores from the lakes? Because that research hasn't been done in Central Eurasia yet. My idea and idea of our team is that there must have been the depletion that was taking place of the whole landscape, all these metal production to take place. But it's something that is remaining for the next 5 years for this ERC project. But let me just remind you, the production efficiency of bronzes in China is yet to be estimated. The Shang Dynasty China bronzes measure in tons, as I mentioned. It must have been a considerable environmental impact. I believe that the impact of what was happening in the steppes in the Bronze Age combined would have been the impact of what was happening in terms of metal production in Nanyang, the capital of the Shang Dynasty. So we have massive, massive impact coming from China and in terms of metallurgy at the time. So slag analyses are crucial for estimating efficiency in addition to the volume of finished objects. We can dive deep into the microstructure and figure out the fuels and look at some of the remains of the charcoal and we can see where the ores were coming from and similar, and that can help us reconstruct the story. But I think more interesting question is like, how can we jointly address the Bronze Age carbon emission throughout Eurasia as a point of like, when did it actually turn wrong? And most importantly, how were societies surviving, and what sort of a resistance we can see in them, and how they were actually going through the time of just complete collapse of this industry, which happened in the late Bronze Age. So I can tell you for the carbon emissions that there are definitely many other sources of carbon emission in the air, but there is around 10 to 15 ppm that is unaccounted for at the time of this Bronze Age rise. And I believe that it could have been due to the production of metals at the time. And it's something that is that I'm actually exploring further. There is more research happening in the region, and drawing on that and also on the partnerships in the region. I have been blessed with the award of this DREAM project. It has been a dream for around 10 years when I started working in Central Asia. And after some attempts, this project was awarded by ERC and underwritten by the UCRI. And I'm very happy to see some of the faces from my project team actually present here today. So the project is about social and environmental impact of the Bronze Age steppes in a metal-driven economy. As I have already explained, it is a largely metal-driven economy. And this will create new knowledge, looking at the evolution of metallurgy, organizational production, environment, networks and society, and using lots of AI, because there will be places where we don't have the data and we need to use some data reconstruction models. But all of that is all serving the gaining of the new data set, new methodology, and the new models. Obviously, I did show you a very simplified idea of what metallurgy looks like, that you throw something into the furnace and then you study what comes out of the furnace. However, it is much more complex. There are so many factors impacting the first smelting, the second smelting, the remelting, then the types of charcoal being used, then where it's coming from, where it's being circulated. All of that broken down is part of this project. So we'll be looking at the process and the product, looking at the organization, environmental impact, and using all these analytical instruments at hand at the UCL Institute of Archaeology. A very interesting work with mechanical engineering at the time and deep neural networks is our preliminary project on Tal Desai, where we use the detailed reconstruction of the metal making process from copper smelting to matting to matte smelting from Tal Desai to teach the machine to recognize the phases, where we would then give the machine just the image of the micrograph and it would predict where it would sit in the process. So this is a revolutionary method for us for the process ID, because within a project, we could at most analyze 300, 400 samples of slags, but we are talking about 4,000, 5,000 perhaps, because we can cut the time of actually looking and analyzing slags. We can use machine learning for that. And we can also quantify the impact on land and climate using these numbers and these estimates, and therefore accurately reconstruct technology, scale, and networks of interaction. This is another theoretical model. So looking at the machine learning is one idea, but then on the other hand, we're going to make the furnace, the one that I showed you from Tal Desai, smelt metal, and then build the model of like how much air and fuel, what temperature, and so on were taking place, so we can actually have a rounded story and very precise story about how much fuel you need for each step of your metal smelting, melting, remelting, and so on. That can give us numbers to actually make a rough estimate of what is happening in the steppes in whole of Central Asia, and therefore project how much carbon emission we might have, and they may have made at the time, and how it was impacting the climate. Another groundbreaking method is with NMTF. It's non-matrix tree factorization, a mouthful method, but is basically explainable AI. We did a little study with a data fusion model, looking at the composition of the Bronze Age artifacts and how they fuse together in terms of the attributes we have attached to the data. So if you remember the site of Dali that I was showing, that was very central in the Silk Roads, the pre-Silk Roads route, we can see in this artifacts network and site network that basically Dali had really a central role. So by using this method and other methods, we actually have the way to confirm hypotheses or basically test the hypothesis and build more knowledge in the area. This is method that is, well, paradigm shifting because it is very robust for heterogeneous data. And coming back to the quality of the data from the region, I can tell you that it is easier to work with more complex AI systems because we don't lose on the precision and the quality that was not initially reported, but we can capture high resolution of operation, predict some novel mining production and supply centers, and create new explanatory models for the scaling up of Bronze Age metallurgy, and also reconstruct the data sets where we don't have them. It was timely, as I mentioned at the beginning, more than a decade of research, collecting the data from the region, more than 40 something sites, that will be actually, we will be growing number of sites, definitely, but also looking at all stages, early Bronze Age to the final Bronze Age in the region in order to build model, and also utilizing geological database from the Natural History Museum in another collaboration. So the expected outcome is a lot of data. The number of studied sites will increase, and the DREAM database will be made open access as required by the funder, but also as desired by us. And DREAM team is not just me. It is a core of very strong and intelligent women. And then I also have affiliated members from different fields, from artificial intelligence, from geology, from GIS, from archaeobotany, from climate modeling, from the kind of general Bronze Age, and I owe it to them, the collaboration that actually was so fruitful that brought this project together. And for, obviously with local colleagues here, I think I took all of the photos while I was visiting them. I take pride in building these personal connections. So the way I kind of believe it was maybe happening, and I asked AI to help me with that, is close to this. I don't see women on the picture, but he didn't want to give me women. But this is how it may have looked like. We think that they were living just in yurts, minding their business, milking their horses, and just collecting kizyak, this dung for to cook a dinner later. But there was something bigger going on, and I can tell you that when it comes to the steppes, the big misconception that I had to overcome is that to see that every site is different. We thought of that place as a homogeneous space where they're all just, herding goats and that's it. And then we have this highly special metallurgical workshop, and we have this little campsite high up in the mountains with still some metal production in the backyard. And we have this in eastern Kazakhstan, the fortified nomadic settlement in the final Bronze Age with like a kind of a pre-urban organization. So it is a mosaic of very interesting things happening in the steppes. And I can tell you that because the steppes are not just the grasslands, but many ecotones, that we have a variety of economies taking place at the time. And that's something that is the world actually opening up for me. And I'm hoping that I will open it up for you as well in the future. Thank you very much.
Thank you so much, Miljana. One of the great joys of coming to lectures here regularly is that we hear fantastic new ideas, and yours is one of those that's really suddenly changed, certainly my perception of things. So thank you so much. It's really, really interesting. A very, very exciting project. Can I kick off the questions with question about, and on a small scale, I've been interested in woodland supply for a long time. And is it possible that they're moving wood over very large distances and huge volumes? Is there a sort of north-south transport of the fuel? Is that something that you've wondered about, something that can be addressed?
Yeah, that's a great question. The massive production that we see is actually in the area that is more forested than the others. So it's not really the grasslands. So I would presume that they still had more access to the local wood.
Right.
That's my first idea. But then this mixture with the dung is an idea that is in the area, and some have been experimenting with it, that it can raise the temperature to the desired stage. So that's one. I am not saying that that the wood supply from elsewhere is definitely not happening. But what this research will be able to show is that when we look at the phytoliths and microcharcoal and so on, we can figure out how local was the vegetation or how local was the charcoal being used. So that could maybe help us. But we're also going to core the lakes and look at the palynological data. So hopefully we kind of square it properly. But it's a great question. Thank you.
Thank you so much. Questions and comments from the audience?
Yes.
Have you looked at peat?
We are going to. Thank you very much. Yes, we have identified, we have colleagues, palynologists from Almaty, who are actually going to help us to identify peats nearby the massive production sites. So not all sites are mass production. We have located them in the south, in the east, and the north of Kazakhstan, next to modern mining. So we're going to look at that and see what we can extract. Yes, there's a lot of field work happening.
Does peat give you a high enough temperature for metal smelting?
Well, it's mostly to look at the pollen.
Yep.
So to look at the trace elements. So ideally, I will be looking, amongst others, at lead.
Yeah.
So the lead pollution may give me an idea of like the movement and the kind of the extension of the metal production at the time. The studies in Europe, but not in Central Asia.
Can I ask a question?
Yes.
I was wondering if you could tell us more about, in terms of climate and carbon emissions, what insights we might gain from your project that can be applied to today.
Oh, can you ask me in 5 years? Well, for me, the fascination with looking at the choices of people of the past is to see the resistance. So what actually happened that took them through the times of collapse? So something was collapsing at the time, we know, it's late Bronze Age. There was a massive transition. And what we can see is that in the times of collapse, you usually have these more comfortable environments going down first, like urban centers, like civilizations. But those who are more adaptable to change, those who are more mobile, they actually get to survive better. So for me, that will be the lesson, looking at the survival strategies, because I don't want to sound like gloomy, but we are where we are when it comes to the climate impact. So what lessons can we learn from those who adapted so fast to move on into a different subsistence economy? So that will be the lesson for me.
Thanks very much for that fantastic presentation on your work, Miljana. So as one of your dreams, is it to envisage a very different picture at the end of 5 years and maybe put some trees into that environment?
Definitely. Well, one of my dreams is to see more women in the production. Definitely to look at the different environments and just to break this idea of them being the same, all the same. Is the steppes, is the grasses, there's nothing to learn. They are just a conveyor belt. And now we actually learn about how inventive they were, because from the beginning, you can see that they had these furnaces that no one else had at the time. They invented new furnaces so they can scale up the production. And their production efficiency was dwarfing everything happening in Europe. That's dwarfed by Chinese, but that's another story. But like, just gives me, just breaks many paradigms and many sort of Eurocentric ideas of, you know, what was happening, how change was happening, and what is civilization. Because they are as civilized as those we consider to be civilized in that sort of a sedentary way, but just in a different system.
Are there any more questions? Anything online? Well, if there are no further questions, can we express our thanks again to Miljana for a splendid lecture. Thank you so much. And I give notice that the next meeting will be on Thursday, the 27th of February, when we'll hear a paper, Heathfield Down 1066, Why This Could Be the Site of the Battle of Hastings, by Dr. Rebecca Welshman and Dr. Simon Coleman. Meeting stands adjourned. There are some drinks outside if you'd like to join us. Thank you.